Welcome everyone, my name is Craig Otto. This is Statistics for SPC, Operational Excellence. Today we're going to talk about the Binomial and Poisson distribution. Basically what we have to understand with these distributions is that we're calculating a probability of something happening. And you'll see that here in a second as I get into it. But and what we're doing when we calculate that probability is we're using a distribution, first as binomial, and you'll see what makes us choose binomial, and then later we have what's called a Poisson distribution, which helps us estimate probability. So that's what we're going to be focusing on for this lesson. Okay, so for the binomial distribution, there's different inputs for this, and we're going to use the calculator. This is also something that can be done in Excel, but I'm going to mainly focus on the calculator. I'll try to make sure I note too when Excel can be used just as easily. Okay, so the first thing that we need for binomial distribution is a sample size. We need to know P, which is proportion defective. We need to know how many defectives are in the sample, which is denoted as R. Then you have two different types of analysis for the calculator or computer to use. One is called a PDF, and that's the probability density function. What that means is it's a probability of a single occurrence of a defect. CDF, however, is a cumulative effect of all those PDFs. So that's like something happening of 2 or less, where you would cum up the probability of 0, 1, and 2. So your calculator does that automatically for you. It thinks from left to right, so when it calculates probability, it always starts with a probability of 0 on up to the R value that you choose. And I'll show that here in a minute too. And the way that you do it on the calculator, it's math stat distribution. And I have some snapshots too, just to kind of show you what the calculator screen looks like. But it's whether you choose binomial PDF or CDF, you just got to know which one you want. And it's NPR, or your arguments. You just put them in that order. So sample size, proportion defective, and defects found. Alright. And I mentioned Excel is also another way of doing this. It's make sure you put your equals in. So equals and then binom dist, and then your arguments are kind of flip-flop. They do that to confuse you. They love confusing people, so that's why they do it. I'm just teasing. But you do have to be conscious of that. It is R value first, then N, then P. And if you want a PDF, you have to type false in. Okay, and then if you want to do a CDF, it's just the same, R, N, P, but then you have to type true. Okay? Alright. Example for the calculator. Find the probability that 2 successes will occur out of 5 trials if the probability of success is 0.3. Okay, so what we do is we go in, go to second vars or distribution, and you should see this menu. You have to scroll down to the A here where it says binom PDF, because we want to know the probability of 2 alone. Okay, so what we do is we hit binomial PDF, select enter, and then we type in 5, 0.3, 2, because it's sample size, which is 5, our P, which is 0.3, and 2 is the number of successes. So you hit enter when you type that in, just as they show it over here. Comes to 0.3087. What that means is the probability of having 2 successes out of 5 is 30%, or 30.87%. Another example, this is where we're going to use CDF. I mentioned last time it was just 2. Now we're saying find the probability of 2 or less. So that means probability of 2 plus the probability of 1 plus the probability of 0. And the calculator actually thinks in reverse order. The calculator adds up the probability of 0 plus the probability of 1 plus the probability of 2. when it's entered in this manner. And what it does is it adds those up because it's a cumulative to get 83%. So the probability of getting 2 or less successes out of 5 is pretty good. It's 83%. Alright. This can get, it's a little tricky at first, but I'm going to try to, I think I've got this presentation set up to try to explain it very clearly. And I also got some color coding going on so that hopefully you can kind of see where my numbers are coming from. Alright, so we got a question here. If a population has 2 out of 9 defective parts, and a sample of 3 parts were pulled from that population, what is the probability of pulling exactly 2 defects? So exactly 2. That should immediately trigger you to start thinking PDF. Okay, so N was 3, because it's a sample of 3 parts. We got a probability of 22%, or you can just type it in as 0.222, or you can actually type it in as 2 divided by 9 on the calculator. That's fine, either one. The R is 2, because we want exactly 2. And we want to use, and I kind of started out with this, binomial PDF, because we're trying to find the exact number. It's exactly 2 defective parts. Okay? So when we do that, excuse me, when we do that, you'll go in, I got to do this here. I'm going in on my calculator, go into probability, and let's see. I want a binomial PDF. I'm going to type this in as N of 3. I'm going to type in my p-value is 2 divided by 9, and my r is 2. So when I hit enter, it should give me 0.1152. Okay, so if you was trying that at home, you should have 0.1152. Alright, so I got some different combinations here of good and bad parts. First of all, if I pulled a sample, I could have all 3 that are good. I could have 1 out of the 3 that are good, and that's what I'm showing right here in different combinations. I could have 2 out of the 3 that are bad, you know, on the pulls. Or I could have all 3 that I pull that are bad. So those are kind of your samples there. But you might ask, what's the possibilities of those? You know, what's the probability of getting 0, or 1, or 2, or 3 bad on 3 different pulls? So here's a question. If the population has 2 out of 9 defective parts, and a sample of 3 parts were pulled from the population, what's the probability of getting exactly 2 defective parts? So that's exactly what I just said, or what I just did, where we have 2 bad. So that's one of those combinations. So there you can see where you plug it in, it's 0.1152. Okay. Let's start looking at this from each combination. I think this is important. So we already figured out 2, but let's consider what the probability is for each of these. So your N and P will stay the same throughout all these, because you're pulling 3. You have a 0.222 defect rate, or 2 out of 9. In this case, we're saying 0 bad, so that's why we plugged in a 0. So when you plug this in, you should get 0.4705. Okay? Do the same thing on the next one, except you're plugging in a 1. So when you plug the 1 in, what it's doing is calculating the probability of exactly 1 bad. So that's 40%, or 40.33. Do it again on the next one. The probability of getting exactly 2 bad, that's your 1152, as we said earlier. And then the probability of getting 3 bad. So you can see 3, so it's 0.0110. Okay? Now, keep those probabilities in mind. What we're going to do is add those up. If you've seen some of my previous presentations or lessons, you remember that probability always adds up to 1, and your individual components have to be between 0 and 1. So if we take the probability of 0 bad plus the probability of 1 bad, 2 bad, 3 bad, that should all add up to 1. Now let's talk about what does CDF do. Okay, so what is this CDF? We really haven't gotten into this. Well, CDF, if you plug in for 0, it's 0.4705. Okay, but if you put a 1 in, it takes the probability of 1 and adds to the probability of 0. That's why, like, the 0.4705 plus 0.4033, that adds up. These add up to this 0.8738. And just like when we put in for 2, so we put a binomial of 2 in here, CDF, it adds up these three numbers to get 98.9%. Okay? And then you add the third in. As we mentioned earlier, it should add up to 1 because it adds up all the probabilities, and you can see it adds up to 1. Okay? Alright, so we're going to stick with this. If a population has 2 out of 9 defective, sampling 3 parts still, so we know it's going to be 3, 2 out of 9, or 0.222, now the challenge is always figuring out what R is going to be. That's always the challenge. So in this case it says pulling less than 2. Alright, so N and P, we know those. Now R, less than 2. Now, how did I get an R value of 1? Well, let's draw it out. And at home, I highly suggest this. Draw your sample size out. So you can see down here at the bottom, I drew it out. I'm pulling 3. And I could have 0 bad, 1 bad, 2 bad, or 3 bad. And what the question asks is less than 2. So what is less than 2? Well, 0 and 1 is less than 2. 2 is not less than 2, so that's my cutoff point. That's why I drew a blue box around 0 and 1. So what do I need to do to calculate that? Well, I need to put in binomial n of 3, p of 2 over 9, and an r of 1, because that's the value I need. Okay? Kind of tricky, but draw it out. Same thing. Now I want less than or equal to. Your n and p are going to stay the same. So 3, 2 out of 9, now what's my r going to be? Draw it out at home. Draw out your sample size. If it's going to be less than or equal to 2, what does that look like? R is going to be 2, but let's draw it out, kind of make sure it makes sense. Less than 2 means the probability of pulling 0, 1, or 2. So you put a box around that. That's less than 2, so that's why the R is 2. Wherever your box is around, that highest number that your box includes, that's the number you plug in for R. And I highly recommend you draw it out because you got to be able to see it. Alright, let's go to the next one. Same thing. N of 3. P of 2 out of 9. Now we're talking about greater than 2. Oh, now they're getting tricky on us. Now it's not a less than anymore. So I'm going to tell you R is going to be 2, but it's going to be a little bit different. Notice the formula. Instead of binomial CDF, it's going to be 1 minus binomial CDF of 3, 2 out of 9, and 2. Now how did I get that? Well, greater than 2 means the probability of pulling 3. Okay, so there's actually a couple different ways you could do this. You could use PDF and just type in 3. But if you're going to use CDF, you have to take the probability of 3, but you can't just, you can use PDF to do that, but if you're going to use CDF, you have to use this, what's in dotted red lines. You have to subtract out the probability of 0, 1, and 2. So that's why you choose 2. So you add this probability up and subtract it from 1 to get this probability. Kind of tricky. But when you draw it out so that it makes sense to you, it should be pretty straightforward. You just got to draw it out and make sure you read the English very carefully. Let's try another tricky one. 2 out of 9, 3, so all that's the same. Looking at greater than or equal to 2. Okay, so I'm talking about greater than or equal to. Whenever you say greater than, a lot of times that means you're going to use that 1 minus. Okay, if you see greater than, you're going to be using 1 minus. 1 minus binomial CDF. Now, when you draw it out, it means the probability of pulling 2 or 3. So that's what we're looking for in the blue box. But because the calculator thinks from left to right, it thinks of probability 0 on up, you have to understand that and say, alright, I need to take what's in my little red box, my dotted box, and subtract that. Because that will give me, remember, probability adds to 1. This whole thing adds up to 1. That's why it's 1 minus. So you're taking this probability and subtracting it from 1 to get this part of it. So again, draw the picture so that you don't get tricked on some of this language here. So yeah, R of 1, subtract it out. Okay, now that was binomial distribution. Now we're going to talk Poisson distribution. And with Poisson, you basically have 2 inputs. Instead of NP, R, you have something called lambda. And actually, it's lambda is equal to N times P. So it's kind of an average rate or a defect rate. And still using PDF, CDF, all that applies, all that's the same. So don't forget about that. On the calculator, I'm actually going to jump. You can use it on the calculator as lambda R, in PDF, CDF, but then in Excel, you can also do it there. It's R, lambda, and then you use false for PDF, true for CDF. Again, be careful because they flip it around from the calculator. They just do that to confuse everyone, but just got to know what you're looking for. Okay, so on the calculator, when you use this, find the probability of successes that will occur if the average number of success is 3 out of 4. Okay, so our lambda is 3 out of 4. So that's why you go in, do your distribution here, scroll down to Poisson PDF. You're typing in the 3 out of 4 as your lambda. That's your rate, or average rate. And then a comma, and then your 3, because that's the probability of 3 successes. And it's exactly 3. That's why it's PDF. So that probability is 0.0332. Alright. Using CDF, same example, only this time you're choosing CDF in the menu. 3 out of 4, comma, probability of 3 or less. So remember, it works from left to right, so that's in our favor. So it's type in 3, and you get 99.27%. Okay, pretty straightforward. Alright, so I'm going to give an example here. If you have a tank that has 5 defects per vehicle, so that's a defect rate, that's your lambda. What is the probability of having exactly 3 defects? So 3 is your R, because it's exactly 3. And you use PDF because we're talking about an exact number. We're not saying less than or less than or equal to, that type of thing, or greater than. So we plug that in, we get a value. Let's go here and kind of build on this example. What is the probability of having less than 3 defects on a given tank? So less than 3, now we're talking CDF again. Now, less than 3 means probability of 0, 1, or 2. Alright, so we're using our value of 2 because we're adding these up. Makes sense? Okay. If tanks have 5 defects per vehicle, what's the probability of having less than or equal to 3 defects on a given tank? Alright, so you got a lambda of 5, again, an R value of 3. How do we get that? You got to look at the language. Less than or equal to 3 defects. So we're talking about the probability of 0, 1, 2, or 3. Draw my little blue box in. So when you type it in on the calculator, it's just Poisson CDF 5, 3. Now you can see I'm not given the answers for these, but to me, it's not about the answers. It's about knowing what the process is. So I mean, you can type these in on this particular example, just if you want to try it to make sure that you're getting the right things. You type in Poisson CDF. You would type 5, 3, and you would get 0.2650 would be the probability. That way, if you want to double check yourself, 0.2650. Alright, building on the same example, what's the probability of having greater than 3 defects? So, greater than 3, now we got to use that. What did I tell you about binomial with greater than? It's always 1 minus. Same with Poisson. It'll be 1 minus Poisson CDF. And what greater than 3 means is the probability of having 4 or more. So I draw my little blue box in, 4 or more. Okay, but our calculator doesn't think that way. The calculator thinks from 0 on up. So we need to subtract from 0 to 3. We need to subtract those probabilities out. That's why it's 1 minus 3, the lambda 5 r of 3, and you'll get your answer. Okay, so when you type that in, it should be 1 minus Poisson CDF 5, 3. And you should get a value of 0.73497. 0.73497. So that's the way that works. Okay. If a tank has 5 defects per vehicle, what's the probability of greater than or equal to 3? So now we got to use an R of 2. Well, why is that? Let's draw it out again. So greater than or equal to 3 means 3 or more. So I draw my little blue box around what I want, the probability I want. Recognizing that it's a greater than and knowing that the calculator thinks from 0 on up, I have to subtract out 0, 1, and 2. So that's why I use a lambda of 2. So it's that same data, 1 minus Poisson 5, 2, and you get 0.8753. Okay, 0.8753. That's how that works. So that's binomial and Poisson. The biggest thing with those is drawing the pictures and paying attention to that language. Next time we'll get into the normal distribution.